I want to define the term moment and give a couple of basic examples. A moment is a measure of any object's tendency to rotate about an axis of rotation or a pivot or a fulcrum. Let's take a basic seesaw. A seesaw is balanced on a single pivot. And let's say that we have two weights on either end of the seesaw, and these weights are going to be equidistant. Now, if these two weights are equal to one another, if the two forces are equal, then the seesaw will be in perfect balance. However, if F1 is greater than F2, then the seesaw will tilt to the left, or it will rotate in a counterclockwise direction. And from now on, I'm going to call this the negative direction. If F2 is greater than F1, then the seesaw will rotate in a clockwise direction, which will now be the positive direction. I want to talk about the different quantities that moment depends on. And we can talk about a wrench as a basic example. You may be familiar with the concept of mechanical advantage. If I apply a force with my hand to tighten a nut from close in, it will not be as good as if I move my hand further away or if I get a wrench with a longer handle. I will have more torque if I move my hand further away and apply the same force. So the same force applied further from the nut will produce more torque or turning ability. What does this mean? It means that not only is moment directly proportional to force, as in the seesaw example, but it's directly proportional to the distance away, the perpendicular distance away from the axis of rotation. In other words, moment is equal to force times distance. So we'll write m equals F times d. The kinds of units that you're likely to see for moment are units of force multiplied by units of distance. We really just put them together. Common examples are foot-pounds or inch-pounds, but the SI unit and the unit that you'll be using in your lab is a Newton meter. Here's a basic example. If I apply a force of 150 newtons 2 centimeters away from the center of the nut, what is the resultant or total moment? Now, righty-tighty, lefty-loosey, right? A force applied, as it is in the picture, will rotate the wrench in a clockwise or positive direction, so the moment will be positive. M will be equal to 150 newtons times 0.2 meters, or 30 newton meters. I want to note that if F were pointed upward, the moment would actually be negative, and so the moment would be negative 30 newton meters.